Alright, welcome back. In this video, we're going to go over naming complex alkanes. So in the last video, I taught you guys how to name the side chains for alkanes. We went over the parent chain and naming the side chain groups. So please watch those videos before watching this one, because this basically puts everything together. So how do you actually name these compounds in the bottom? That's what I'm going to teach you in this video. So there's a few rules we have to go over first so you can actually easily name these complex alkane structures. The first thing we need to do is actually talk about numbering the parent chain. So we need to actually know how to properly, in what order, to number the parent chain. So here's rule number one. If there is only one side chain, the side chain must be assigned to the lowest number. In other words, lower the number, the better. So here we obviously have a methyl group here. It's the same exact molecule, the one on the left and the one on the right is the same molecule. But notice how I numbered them. From left to right is the correct way. So the smallest number being the one on the left. So we go 1, 2, 3, 4, 5, 6, 7. This is the correct way. The incorrect way would be doing numbering from the right hand side. 1, 2, 3, 4, 5, 6, 7. Why is this incorrect? Well, the reason is because the methyl group must be assigned to the lowest number. So here the methyl group is assigned to carbon number 2. Here it's assigned to carbon number 6. 2 is lower than 6. So the way you number the parent chain will be this way, on the left-hand side. So we have to make sure the side chain is assigned to the lowest number. That's it. So that's rule number one. Rule number two is if there are multiple side chains, the parent chain must achieve the lowest number possible. And if there's a tie, the second chain needs to be the next lowest number. So let's break it down slowly. This is a little more, I know this is a little complicated. Here we have the two exact same molecules here, okay? Here and here. Carbon 2 here has a methyl group, and here carbon 5 has two methyl groups. Here we have the same exact molecule, but except now carbon 3 has two methyl groups, and carbon 6 has one methyl group. It's the same thing, I just numbered it differently. So instead of, increase from left to right, I am decreasing left to right. All you have to do is realize what number is the lowest. So you can ignore all the other numbers. So here, the methyl group is on carbon number 2. That's the lowest number we can achieve with this configuration. Don't worry about the 5 here. This doesn't matter. The lowest number is 2 in this configuration. If you were to configure it and name it from highest to lowest, from left to right, the lowest number is 3. Here. Even though there are two 3s, it doesn't matter. The lowest one wins. No matter what it is, the lowest one will win. So you need to find a configuration to name the parent chain so the lowest number is applied to the side chain. I hope this makes sense. This one's probably the most difficult one. But in other words, lowest always wins. So find a way to name the parent chain or number the parent chain so it's the lowest. And it's, by the way, another thing is it's not additive. So it's not like, okay, this equals 12, right? Oh, whoops. 2 plus 5 is 12, right? And then this 9, 12. You see, it doesn't work. So you can't do that. It's not additive. It's just the lowest number. Okay, awesome. Rule number 3. If the tie is not broken, assign the numbers via alphabetical order with respect to the side chain. In other words, you need to try to number the carbons so the lowest number goes with alphabetical with respect to the alphabet. So for example, we have a methyl group. So we have a methyl group here and an ethyl group. The ethyl group starts with an E. The methyl group starts with an M. So ethyl is before, so the E in the alphabet, in the American English alphabet, is before M. Ethyl wins. So this means ethyl will be on the lowest number carbon. Okay, so you see, the reason this is incorrect is because we have the methyl group on carbon number 4. That's cool. But the ethyl group is in carbon number 5. Ethyl, the E comes before M in the alphabet. So ethyl must be on the lowest carbon number possible. So we're gonna number this from left to right. All right. Rule number 4. If there are more than one of the same side chain, we use the prefix di, tri, or tetra, or so on. For example, we have 2 methyl groups here. So we call this 2,3-dimethylpentane. Because it's a pentane because we have 5 molecules, 5 carbons in the parent chain. And it's a dimethyl because we have 2 methyl groups, di meaning 2. Now, how we name this is we first need to number it. So we number the parent chain, then we need to look at where the side chains are coming off of the parent chain. So we have a side chain coming off of 2, and we have a side chain coming off of 3, and it's the same side chain. So we do this, how we basically label this or name it is we do 2,3-dimethylpentane. So to separate the numbers, we use a comma. But when you separate a number and a letter, we use a hyphen. This is very, very, very important you remember this. It's just the rules. I don't know why, but this is the rules. Whenever you're separating numbers, we use a comma. And if you're separating a number and a letter, we use a hyphen, not a comma. So here's an example here. What's the parent chain here? So we have 4-ethyl 2,3-dimethyloctane. So this right here gives it away. Octane means 8. So the carbon chain, the parent chain will have 8 carbons. Okay? We have a 2,3-dimethyl. So that's 2 methyls. And we have a ethyl on carbon number 4. So the number always comes first and then the group. That's how you read it. So we know there's an ethyl group on carbon number 4. And I see an ethyl group right here. We also have a methyl group on carbon number 2 and carbon number 3. So I see that we have a methyl group here and a methyl group here. So let's work this out. So we know that the parent chain, so if we know there's a methyl group on carbon number 2 and 3, we can't do this. 2, 3, 4, 5, 6, 7, 8. Oh, 8, right? That's terrible. I'm sorry. Because this would put it at carbon number 7 and carbon number 6, and the ethyl will be on carbon number 5. So this is not going to work like that. It won't work like this. Okay. But we can do this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, because we got a methyl on carbon number 2, so we got that. A methyl on carbon number 3, we got that. And then we have an ethyl group on carbon number 4. So that's how you solve this one. Here's some practice problems. Name the compound. Okay, so the first thing you do is first identify the parent chain. What's the longest carbon chain here? It is 1, 2, 3, 4, 5. No, okay. So it is going to be 1, 2, 3, 4, 5. Yeah. You can do this actually multiple ways, but this is the correct way here. And this is called 3-isopropyl 2,4-dimethylpentane. Okay, so first we know it's a pentane because it's it's 5 carbons. 1, 2, 3, 4, 5. We have an isopropyl group on carbon number 3 right here. This is an isopropyl group. It looks like a tree. A propyl, meaning 3 carbons. So we have 1, 2, 3. We don't count the parent chain. So 1, 2, 3, and it branches like a tree. That's an isopropyl group. It's on carbon number 3. We have a methyl group, so methyl, on carbon number 2 and carbon number 4, and that's why it's called dimethyl. And then we just put the parent chain at the end, which is a pentane. Okay, this one. This one, let me make sure, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Okay. This one is going to be 1, 2, 3, 3, 4, 5, 6. This is the longest parent chain, and we're making sure that the methyl groups here are on the lowest number carbon, which is 2. So the answer is not this. If you were to number this, 1, 2, 3, 4, 5, 6. This is wrong because the methyl groups will be on carbon number 5. That's too high. We need to make it as low as possible. Oh, and additionally, we have an ethyl group here, right here. So this, 1, 2, 3, 4, 5, 6. So this would be ethyl group on carbon number 4 compared to 1, 2, 3, 4, 5, 6. An ethyl carbon on number 3, on carbon number 3. And remember, alphabetical wise, the ethyl, E, comes before M in methyl, so it should be assigned to carbon number 3. So the name is 3-ethyl 2,2-dimethylhexane. Hexane means 6 carbons. Like I said, we have the ethyl group on carbon number 3, and the 2 methyl groups on carbon number 2, and we say dimethyl. And yes, you do write 2, so twice. This one's tricky. What do we do here? Now, you probably are looking like this. Oh, you're probably looking and saying we should name the carbon chain this, 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 and this. No, that will not be correct because we can't name the rest of the molecule like this. So the order is going to be this. Oops. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's an octane. Okay. How do we name this? How do we name this big, huge chunk here? So first, let's break down what we actually have here. We have an ethyl on 4, a methyl on 5, and a methyl on 6. But what about this? How do we name that? Okay. This is what I did not tell you. It's a little trick question here. Something you would probably see on an exam. How you name this huge ring structure is you have to put the prefix cyclo in front of it. And since this is a 6-carbon ring, 1, 2, 3, 4, 5, 6, we call this the hexyl. Hex meaning 6. 2-cyclohexyl, so because it's on carbon number 2, 4-ethyl, 5, 6 dimethyl octane, because it's octane meaning 8 carbons. Okay. What about this one? Okay, so you're probably thinking you should do this. 1, 2, 3, 4, 5, 6, 7. You're probably thinking you should do this. This would be incorrect because we can't, do you see how it branches off here, go here, and comes back here? We can't have that. Okay, so a side chain cannot do that. So what we have to do is we actually have to number this like this. 1, 2, 3, 4, 5. And that is the parent chain. So we have a branch coming off of here on carbon number 1, because that's the lowest, we can get it, and carbon number 3. So this is called 1,3-diisopropyl cyclopentane. 1,3 because we have a branch coming off of carbon number 1 and a branch coming off of carbon number 3, and that's an isopropyl group. And since we have 2 of them, and it's the same functional group, we call it diisopropyl. And it's a cyclopentane because we're in a cyclic formation here, in a ring. And it's a 5-carbon molecule. And once again, let me reiterate why we can't name it like this, number the carbons like this. Why can't we do this? 1, 2, 3, 4, 5, 6, 7. Because it's a bigger parent chain. You would not be wrong. But the side chain that branches off from 3 here goes here, here, and joins back with 5. The side chain cannot join back like that. That is why it's not correct. All right, here's a challenge. And the reason I'm doing this is you're not supposed to know this, by the way. If you get this right, I'll be impressed. But you're not supposed to know this. Because this is a very complex topic. This is like chapter, what is this? Like chapter 18 or something. So we're far from this. Very, very far. But I want to tell you why the naming convention, like what we just learned, does not always work for all the functional groups. And this only works for alkanes, mostly. How do we name this? So you're probably rushing to think, okay, we have this, 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 and this. Boom, that's our parent chain. Okay, this is not correct because the carboxylic acid here gets priority. So there's something called priority. And in organic chemistry, carboxylic acids always need to be on carbon number 1. Always, 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 always. Okay? So this would make carbon number 1 and carbon number 2. This itself is a functional group. Okay? It's not part of the parent chain. This itself is a functional group. I know you may be thinking, you'd be rushed to think, okay, this would be 3, 4, 5, 6, 7, 8. The parent chain cannot include an entire circle like this, a cyclic molecule. So it's only 1, 2. So the parent chain is only 2 carbon molecules. I told you this is a little complicated. This is called 2-phenylethanoic acid. You probably, if you ever watched Breaking Bad, you may be familiar with this molecule. Because in one of the episodes, I believe when Jesse goes to Mexico, he says, "Get me my phenylacetic acid." It's the same thing. This is a different name. This is the IUPAC name for this, called 2-phenylethanoic acid. Okay? So this is ethanoic acid because we have an ethyl group here that's part of a carboxylic acid. So we call it an ethanoic acid. And the phenyl group is this part right here, and it's joined on carbon number 2. And a little fun fact, if you were to take all of this out right here and only have this part, that's called acetic acid. And if you've never watched Breaking Bad, it's a show about meth, okay? And what I'm showing you here is a precursor to actually making meth. It's one of the things you need. When I get popular and probably like 1,000 subscribers or 10,000 subscribers, I will teach you guys how to synthesize meth. I will not hold back. That's my promise. Because we're here about education, right? I want to teach you guys stuff. I want to teach you the fun stuff. But please be responsible. Don't go make it. But okay. If you found this video helpful, please like and subscribe. And until next time, later.